Hello, my name is Andrew Fleming, and I'm going to give you a quick overview of the Polar Thematic Exploitation platform, quickly to acknowledge the contributions from my colleague Andreas Safursky and David Arthurs from PolarView. It's becoming clear that the volume of Earth observation data over the planet, but especially over the polar regions, is increasing dramatically. This graphic gives a quick overview of the heat map of Sentinel-1 coverage over the Arctic on the right and the Antarctic on the left. This gives you an indication of the density of coverage, which has grown considerably. So we have a much larger volume of data available, and in line with many other communities, for example the astronomy community, recognizing that the inertia is with the data, the idea is to leave it in place and bring your analysis tools and code to the data itself. So a number of initiatives have started in recent years to facilitate this. One of them being the ESA Exploitation Platform program, where they initiated 7 thematic exploitation platforms, and Polar is one of those. And the idea being to develop a virtual research platform which allows users to bring their own code and analysis tools to the data and access it along with necessary computing power, storage, etc. So why Polar amongst all the other themes that are under development? Well, the polar regions play an incredibly important role globally, driving and regulating the climate, but they're also undergoing significant changes. For example, changes in Arctic sea ice extent, and that drives a range of new opportunities and economic development. For example, expansion of shipping in the Arctic thanks to reductions in sea ice extent. So it's necessary to have good information to inform this, to monitor changes, and to allow good political and economic decisions and investments to be made. And Earth observation plays a critical role in that. Earth observation has a rather unique role in the polar regions. It's really the only way of providing regular monitoring, regular observations over the entire region throughout the polar year under harsh conditions, regardless of the light conditions or the weather conditions. So providing good access to this sort of information and the tools to extract the necessary information is increasingly important. So what does Polar TEP look like? Well, there's a online data access section which allows users to search a range of data sets using established tools such as an interactive map, drawing your area of interest, setting a time range, and saving your search results, or even saving the parameters of that search results for use at a later point. It's also possible then to use a number of existing processors or analysis tools to derive information from the data that you've discovered. So a number are shown here in the top right panel, but it's also possible for a user of Polar TEP to access a virtual development environment whereby they can develop their own processors and then execute them on the data that they've discovered. And once you have set up some processors to run, whether it's on a single satellite image or on a much larger batch of data, the user can track the progress of those processing jobs and see the results and download the results or have them pushed to a third-party storage if that's what they require. As well as triggering them manually through the Polar TEP interface, it's also possible to set up automatic triggers using cron tab type time triggers to allow them to run automatically. New features are constantly being added to Polar TEP, and this is driven largely through parallel projects that we're involved in. And to give you a couple of examples of where these developments are active, one with the Canadian project called SeaCaddy, which aims to greatly expand the range of polar data that's available and integrating the SeaCaddy catalogue into the Polar Thematic Exploitation platform. And then a second project, the Horizon 2020 Extreme Earth project, which is developing new machine learning methods for extraction of information from Copernicus data. And that involves integration of the HopsWorks machine learning platform, which provides tools to develop new machine learning algorithms And highlighting one area where this has been successfully used is part of the ESA AI for Arctic activity, and a recent side event highlighted the use of these tools for developing new algorithms for extraction of sea ice information from satellite imagery. So that concludes my presentation. Thank you very much for listening. Please visit polartep.io for more information, or if you have any questions, contact us at support@polartep.io. Thank you very much.